8.6, so we're going to talk about linear equations a little bit more. So we'll start with an example. So this one says, on a comprehensive final exam, a professor asked each student to state the number of hours they spent studying for the exam. She then used the data on the student exam scores and study times to create the following model that can be used to predict an exam score based on the number of hours studied. Okay. So we're given that their test score is equal to 4 times the number of hours they study plus 62. So if they study for 0 hours, what we can do is plug in 0 for h. So we get 4 times 0 plus 62. So we get the exam score is just 62, right? So their exam score is 62 if they don't study at all. So that's their average. If we study for 1 hour, we plug 1 into h, which is 4 times 1, which is 4. 4 plus 62, we get 66. Okay. So I guess I can do that over here. So t equals 4 times 1 plus 62. Okay. If I study for 2 hours, well, then we get the same thing, except we have a 2 instead of the 1, right? So 4 times 2 plus 62. So 4 times 2 is 8. 8 plus 62 is 70. So hopefully you see this kind of pattern that emerges where we're just adding 4 each time, right? So we just have a linear function, right? So we get 70, it goes up to 74, up to 78, up to 82. Okay. So we just get this pattern forming. And then we can kind of examine this a little bit more, right? So B says, since the exam scores increase by 4 each time, every time the study hours increase by 1, right? So every time we increase the study hours by 1, we get an increase of the exam score of 4. So we can say that there is a slope of 4, right? So 4 divided by 1 is 4. It's our slope. And we can say that there is a linear relationship, right? So it's just like our linear functions and stuff that we had before, our patterns, right? Okay.
Is
So
this
now,
linear? Is this linear rather than the exponential? Because the exponential would be multiplied by something.
yep, absolutely. Yeah, so you'd have a multiplier every time,
Okay.
whereas this one's an additive.
Okay.
Yep.
Thank you.
Yeah. So it says since 0 study hours leads to an exam score of 62 in this case, we can say that the starting or initial value is 62, right? So just our initial value is 62. It's what we start with. So if we kind of look at this, we're kind of going to quantify what this exact equation is, right? So we'd say that our 62 is our initial value. H is just our variable, right? And 4 here, we already know is just our slope. That's just how much we're increasing by each time. Okay, any questions on this page? Okay, so C says, use the model or table of ordered pairs to graph the equation. So what we can do is, I'm going to kind of go off the top of my head here. So we start with our original value of 62, right? That's our starting value. So if we study for 0 hours, we get a score of 62. If we studied for 1 hour, we get a score of 66. If we studied for 2 hours, well, we get a score of 70. Right? If we study for 3 hours, we get a score of 74, and so on up, right? So what I can see is I'm just kind of moving diagonal in this line. So if I keep going in this diagonal, go all the way up. So we see the slope is just this increase in this line, right? So this slope is just my rise. So if I look at it like this, my rise divided by my run, right? So we just have 4 divided by 1, right? So that's where the slope is in this equation. And then my starting value is just wherever x equals 0, right? So my starting value is just that very first point. So I'm going to say my slope m is equal to 4. And my starting value, I guess I'll label it b. You'll see why a little bit later. But my slope is, or my starting value is b, and that's equal to 62 in this case, right? And we see that in our equation, right? We see that our slope is 4, and our starting value is 62. Right? So we start to form this pattern here that we're going to see a lot more, where we always have our slope in front of our variable, and our starting value is just added right after that. Okay. Okay. So this slope, or one of the special things that we have about these graphs, is we have places called intercepts, and our intercepts are just where they cross the x and the y axis, the axes, right? So if I look at this example here, my y-intercept here is just where it crosses the y-axis, and my x-intercept is where it crosses the x-axis. And you're given two special formulas, or two special ways to remember this, I guess. So our x-intercept, we have some x value, right? We don't really care what that is, but we have a fixed y value of 0. Okay? And then similarly for our y-intercept, we have an x value of 0, and then we just have some y value. So we don't know what our y value is, but we know that our x is 0, so it has to be on this line. Okay, okay, questions on this page? Okay. Okay. So this one says, complete the table for this equation and identify the slope and the intercepts of the graph of the equation for 2x plus 4y equals 12. Okay. So what I can do here is I'm given all my x values, right? It's going to be 0 through 6, but I don't know what my y values are. So what I can do is I can just plug in these values, right? So that'll plug in all the values for x, so we don't have to worry about x. And all we have to do is just find out what y equals. So we're just going to solve for y. Okay. Okay, so if I plug in 0 for x, we get 2 times 0 plus 4y equals 12. Right? So we get, that cancels out, and we get 4y equals 12. So we'll just divide both sides by 4. We get y equals 3. Okay. So y equals 3. Okay. If I do that for x equals 1, we plug in 1. So 2 times 1 plus 4y equals 12. Okay. So now I'm going to subtract 2 on both sides. Right. And then we get 4y equals 10. Divide by 4 on both sides, we get y equals, 2.5? Yeah. So we get y equals 2.5. And we know that this is a linear equation, right? So I know that we're going to decrease or increase by a certain amount every single time. So what did I decrease by from x equals 0 to x equals 1?
Half.
A half, right? So I know that for x equals 2, I'm going to decrease by another half. Right? So if I go up one more, I'm going to decrease by a half again. So I go down to 2. And then if I increase 1 over here, I'm going to go down a half over here. So I go down to 1.5. And then 1, 0.5, and 0. Okay. So now I filled in this whole chart. But maybe there was an easier way to do this, right? So we kind of did the first two. We had to solve a bunch of things. Maybe there's an easier way to do this. Because we need to know what the slope and the intercepts are, right? So I guess I got a little ahead of myself. So what is the slope here? So what is my slope in this case? Well,
It's slanting down.
What is it?
It's slanting downward.
Mm-hmm.
Is that what you mean?
So I want to know what value we give to the slope, right?
Oh.
So what am I changing by each time?
0.5.
Negative 0.5, right? Because we're going down.
Okay,
Yep.
fine. Okay.
So my slope here is negative 0.5. Right? My x-intercept, remember my x-intercept, I have a y value of 0, right? Let me go back and look just to make sure. For my x-intercept, yeah, I have a y value of 0. So it looks like I have a y value of 0 down here, right? So my x value is 6. So my x-intercept is 6, 0. And similarly, my y-intercept is where I have an x value of 0, which is the very first one. So it's 0, 3. Okay? So those are the three important things of this equation: my intercepts and my slope. Okay. So if I wanted to make this even easier on myself, if I wanted to know the y-intercept and the slope without having to do all this work, I can do something to this equation up here. I can make it a linear equation that's written in slope-intercept form. In this slope-intercept form, we just get y by itself on one side, okay? And then we set that equal to our slope, which is m, okay, multiplied by our variable x, and then we just add some constant b over here. Okay? And I can just show you how to do that with this equation that we have up here. So this will be my example. So I'm going to rewrite the equation that I had up at the top. So I have 2x plus 4y equals 12. Okay? And all I want to do here is just solve for y. So how can I start solving for y in this equation? So how can I start getting y by itself? Anyone have any guesses? Well, I can start by subtracting 2x on both sides, right? If I subtract 2x on both sides, then I just have 4y on the left. So I have 4y on the left, and on the right I have a negative 2x plus 12. And I'm writing it specifically like that instead of the other side because we kind of want to get it into this form right here. Right? So now we're really close to these two forms. The only thing I need to do is just divide by 4 on both sides, because then I'll just get y by itself on the left. And on the right, I'll get negative 2x divided by 4, which is a negative 1/2 x. And 12 divided by 4 is 3. Right? Because we have to divide both things by 4. Okay. And what I notice is that I have a slope of a negative 1/2, which is exactly what we found up here. And I have a y-intercept of 3, which is exactly what we found up here as well, right? So this equation is super helpful because we get our slope and we get our y-coordinate, and we didn't have to do all this work of creating a table, right? So this is super helpful. So this is our slope and this is our y-intercept. Okay, any questions on this page? Okay, so we can use this to find the answer to some of these equations, right? So it says for each linear equation, identify the slope and the y-intercept. So my slope here in the first one, so m, is just whatever number's in front of my x, which is negative 3. So my slope is negative 3 here. In b, my y-intercept is just negative 2. Okay, what about on the next one? What's my slope on the next one? Anyone know? Maybe it would help if we rewrote this a little bit. So what if I rewrote this as y equals 1/2 x minus 8? Right? So just dividing by 2 is the same thing as multiplying by 1/2. And then the slope becomes pretty apparent, right? It's just 1/2. It's the number in front of the x. So my slope is 1/2. and my y-intercept is just my constant, which is -8. Okay, and then in the final equation, so the final equation isn't written in slope-intercept form, right? We always have to have the x first. So what I can do is I can just switch the order. So I can say y equals, I just switch it, so I have -x plus 4. So my slope m is equal to, it looks like it's -1. So it's just the coefficient in front of our x, which is -1 in this case. And b, our y-intercept, is equal to a +4. Okay. Okay. Any questions on this page?
No.
Okay. All right. So we'll move on then. So this one says graph the linear equation y equals a -5x minus 6 by first plotting points and then by using the slope and y-intercept to draw the graph. Okay. So I'm just going to use the slope, or I guess I'll use the y-intercept first, right? So the y-intercept is -6. So that means I'm going to have a point 0, -6 on the graph, right? So that's going to be down here. And then remember our slope. If we have a slope of -5, well, that's the same thing as saying -5 over 1. And that's our rise over our run, right? So -5 divided by 1. So my rise, I can go down 5 and right 1. Sorry about that. I can go down 5 and right 1. So if I go down 1, 2, 3, 4, 5 and right 1. So that's one of my points, right? But this is also the same thing as saying 5 over -1. So if we kind of go backwards, so I can go up 5, so 1, 2, 3, 4, 5, and over 1, right? So I can get this line of something like that, right? And I could also find that if I just plugged in points, right? So like, let's say I wanted x to be -1, right? So I could just plug in -1. We get 5 plus, or 5 minus 6, which is -5 multiplied by -1 is a +5, minus 6 is a -1, right? So we get that.
I'm sorry, Matt. I'm sorry. You lost me. So the first one is 0, -6, correct?
Right, because that's just our y-intercept from our equation.
Okay, so the second point.
Mhm.
Plotting that one on the line? Are we plotting that at -5, 1?
Yeah, so our slope is -5 over 1, right? Right, because we want to make this so it looks like it's rise over run. Right? So we have rise over run. And our rise here is -5, right? So that would be corresponding to go down on the graph. And then a +1 is our run. So we would go right 1 on the graph, right?
Okay.
So that might be a little bit confusing. I don't know if it came up before. I don't think it has. So what we could do instead is we could make a table, right? So maybe that'll be a little bit easier. So I'll make a table. So I'm gonna have when x is 0, right? So I'm gonna put that in the middle. We get our y values. This is -6, right? So that's just our y-intercept. Okay. So if I have x is -1 and then x is a +1, I want to know what my y values are going to be, right? And the way I can do that is just plugging those two x values in to this equation that we have up here, right? So I can say y is equal to a -5 multiplied by a -1 minus 6. Right? So that's for the x is -1. So -5 times -1 is a +5 minus 6, we get -1. Right? So x is -1, y is -1. So that's this point right here. That one right there. Okay. And then similarly, if we plug in a +1 here, we get -5 times 1, which is -5. -5 minus 6 is -11. So when x is 1, y is -11, which is this point right here. Okay. And then we can just connect the dots since it's going to be a straight line. Okay. All right. Any questions on this page? Okay. Okay, so what if we have some word problems and we want to create a equation in a slope-intercept form? So this one says model the cost if you buy an iPod for $200 and download songs for $1.29 each. So which one's my slope here? The iPod or the downloading each of the songs? So my slope is going to change, right? Which one's going to change over time? The cost of the iPod or the downloading songs?
Downloading of the song.
Right, so my slope is going to be $1.29, right? Because it just depends on how many songs that I buy. And that just means that my y-intercept, B, is going to be the $200, right? Because it just starts at $200. So if I wanted to model this in slope-intercept form, I can say y, or in this case, I think I'll do c for the total cost, is going to be equal to my slope, $1.29, multiplied by x, or in this case, I'm going to do s for how many songs you buy, plus the $200 that you spent to buy the iPod, right? So the cost is equal to $1.29 times the number of songs that you buy, plus the $200 it costs to buy the iPod. Okay, so we can do something similar with part B, right? So this one says model the weekly salary of a salesman if he earns a salary, or if his salary is a combination of his base salary and his commission on his sales. So it says his base salary is $500 and he makes $50 for each sale. So what's my slope and what's my y-intercept in this case?
You're right.
What is it?
Your slope is 50.
So what changes is just how many sales he makes, and that means that the B is $500, right? Because no matter if he makes 100 sales or no sales, he's always going to make that $500 from his base salary. So we can say that his weekly salary, I'm going to label it W here for weekly salary, is equal to 50, right? That's our slope, multiplied by the number of sales that he gets, plus the $500 a week that he gets for his base salary. Right? So that's our equation for that one. Okay, any questions on this page? Okay. All right, so this one says, suppose you have this equation, y equals 2x plus 4. So part A says graph the equation using the slope and y-intercept. So I've already done that for you over here. B says pick an ordered pair that appears to be on the graph. So somebody name an ordered pair that appears to be on this line. So
Negative 2, 0.
Yep, negative 2, 0. Okay, so we're going to go with that. And then it says, confirm that the ordered pair is a solution to the equation, right? So what we're going to do is we're going to plug in those two values that we have, and we're going to plug that into this equation up here. So I know that my x value is negative 2 and my y value is 0. So I'm going to say 0 equals 2 multiplied by negative 2 plus 4. Okay? So we have 2 times negative 2, which is negative 4. Negative 4 plus 4 is 0. Okay? So we get 0 equals 0. Okay? Okay, so that's a true statement, right? So that makes sense. Okay? Another ordered pair, I'm going to choose one a little bit harder. I'll do the negative 1, 2. So this one right here. So I'm going to say that I think negative 1, 2 is on the graph. Okay. And the way I can check it is just plugging it in just like I did with this one. Right? So we plug in a y value of 2. We plug in an x value of negative 1. Yeah. And then we add 4, right? Okay. So if we solve this, we have 2 on the left still. On the right, we get 2 times negative 1, which is negative 2. Negative 2 plus 4 is a positive 2. Right? So this is another true statement. So D asks, how are these points on the lines related to this equation? Right? Well, it looks like whenever we have a solution to the equation, it's on the line, right? So any number, any two numbers that are on this line for my x and my y values are going to be a solution to this equation, right? So all the points on the line are a solution to the equation y equals 2x plus 4. So how can I determine if negative 100, negative 196 is on the graph of this line? So what can I do with that point to find out if it's a solution to this equation?
Plug
Well,
in the numbers.
absolutely, just plug in the numbers. So I'm going to plug in negative 100 for x and a negative 196 for y, right? So I get negative 196 equals 2 multiplied by negative 100 plus 4, right? So 2 times negative 100 is negative 200. Negative 200 plus 4 is negative 196, right? So we get negative 196 equals negative 196. And what does that mean?
Right.
So it's a true statement, right? And that means that this point is on the line. So that point is on the line.